Hello everyone. My name is Caitlin McDonald's. Yes, that's my name, Caitlin McDonald's. I am a professional animator at Pixar Orlando, Florida. And I'm gonna explain the Hooke's law. You have to be aware that this is how you make the formula. F is equals to K times X. It's times, but you don't write it because it's invisible. Now, I'm going to explain what this means. F means force. Force is represented by newtons. Oh, I'm sorry. That's not the way you write newtons. That's it. Very good. So, you spell it like this, right? In English? Yes, it's okay. Now, the next step is X. X, what it means is the measurement, like centimeters, meters, feet, etc. Now, what we're going to do is to mean K. What K means is the constants of proportion. Proportion. Yes, in English, how do you spell proportion? Prop, prop, proportion. Proportion. Is it okay in English? Yes. So K means proportion, and now we're going to graph. Okay. So we have a spring. Because this is Hooke's law. Hooke made the spring law. And this is the equation. So this is our spring, and we're going to add weight at the end of the spring. This can be X number and kilograms, the measurement. And this is going to be represented as the force that goes down, which means that this is going to be represented as newtons. And this part is the X. There is going to be represented as centimeters or meters, which is the displacement. Then it has the force that goes up and down. The force is represented as newtons. Do you have an eraser? Okay, let's erase this. So I work at Pixar. And here we apply the Hooke's law. I am going to explain to you how do we made it. Imagine this is a character from a movie. And our character needs hair. What Hooke's law is going to make is the hair to look natural. So this needs to bounce and it's going to be up and down. So we're going to apply the Hooke's law to little segments of hair that are going to be in just one hair. So we made a lot of these segments, but we need to stretch and compress. How do we do that? Oh, we use the Hooke's law. So we tried using springs connected to another spring. So that way the hair is going to look natural waves. So we applied weight at the end of the spring to make it more natural, that is going to bounce naturally. But we thought that using only springs is going to look very crazy, but we don't want that. So what we did is to add to spring little springs between each segment of the spring, and that way it's not going to bounce too much and the hair is going to look more natural and more realistic. So we use two types of springs, one inside of another, connected to each other like this. So that way the hair is going to look realistic and is going to have more personality to the character.
Oh my god, here is the great granddaughter of Dr. Hooke, the scientist. Can you tell us who Hooke was?
We are at Rebecca's Hooke's home. She is gonna explain us who was his great grandfather. And that is, yes, Robert Hooke, the famous scientist who discovered the law of spring's mass. She lives in a little house and she likes occasionally to read in her kitchen. Rebecca's family says that she is a very special character in her house. When she's alone, she does weird things.
Hi, my name is Rebecca Hooke. I am the great granddaughter from Robert Hooke. He told me all his theories.
Robert Hooke was a Renaissance man, a jack of all trades and a master of many. He was born in Isle of Wight, England, on July the 28th of 1635. He was an English natural philosopher, architect, and polymath. He was the one who created Hooke's law. Duh. In 1660, Hooke discovered Hooke's law, which states that the tension force in a spin increases in direct to the proportion to the length that is stretched in.
Great